Good evening, dear participants. Myself, Dr. Sunil Manohar Reddy, today's session chair. Am I audible to you?
Yes, sir.
Yes, sir, you are audible.
Yes, sir.
Okay. Okay. There are a few instructions before starting the session. Each topic will be presented for 15 minutes, wherein first 10 minutes you are going to present for that particular topic, and next 5 minutes would be about the queries. And one more thing is, I request all the other participants to mute their mic while a certain person is presenting their topic. And first, we start with paper ID 239. Author is Vaibhav. Can you start your presentation, Mr. Vaibhav?
Yes, sir.
Yeah, fine. You can go ahead.
Okay, sir. Sir, are the slides visible, sir?
Yes, they are visible and clear.
Yes, sir. Okay, sir. Good evening. Good evening, committee members, organizers, and reviewers. I'm Vaibhav Chemboli, a Geetam final year student, and I recently completed my graduation. I'm one of the author of the paper titled Conditional DCGAN for Targeted Generation of MNIST Handwritten digits. And one second. Yeah. Uh, Coming to our research aim, we started aiming to generate the handwritten digits using GAN model. Actually, creation of handwritten numbers has been difficult over the years. We can't use normal neural networks to generate a realistic handwritten image. For this, we need to use a GAN model. But there is a problem with a GAN model that it generates output from latent space. That is, the output generator is fully random. So in this research, we used another type of GAN, that is conditional GAN. The main purpose of the conditional GAN is to train the GAN model along with the labels. In this research, we aim to generate the images along with we aim to generate the images for a given number. That's why we title the project Targeted Generation of Numbers, handwritten digits. For this purpose, we selected a MNIST dataset. The good thing about the MNIST dataset is it provides labels along with the handwritten images. The MNIST dataset contains 70,000 images, in which 60,000 images are for the training and 10,000 images are used for testing. And coming to the CGAN architecture, it basically has two components, the discriminator model and the generator model. The main purpose of the discriminator model is to classify whether the image is real or fake. And the main purpose of the generator model is to generate an image. Here, there is an important thing that we need to notice, that the output of generator model is connected to the input of this discriminator model, which is why the shape of the output of generator model and the shape of the image of the which goes into the discriminator model should be same, or else there could be an error. And the generator should generate the images till the discriminator classifies that particular image as a real image. This is an CGAN architecture, and you can see label component everywhere, which implies that we are training our GAN model along with labels. The main purpose of training images along with labels is the GAN model can understand, if we give a number 5, it understands that it should generate the number 5. We train the images from 0 to 9, and our GAN model can generate the images from 0 to 9 basing on the given input. Here you can see the generator and the discriminator models, the layer configuration of the generator and discriminator. These are nothing but CNN models. A GAN is built using 2 CNN models. These are the layer configurations. In the discriminator, the image is the features of the images is stored using convolution layers. The shape of the image goes down, and once the flattened layer occurs, the 2D matrix will be converted into a single list, and this list goes into the input of the generator. Once the generator gets the list as input, it again reshapes back into a matrix form, that is an image. It again restores the features of the image using convo 2D transpose layer. It basically helps in restoring the image with the features that the discriminator saved. And my fellow friend and co-author Samuel will proceed to explain why we took activation function leaky ReLU instead of ReLU, and why we took binary cross entropy instead of other loss functions. On to you, Samuel.
Thank you, Vaibhav. So, hello everyone, I'm Samuel. So, here is a brief explanation of the hyperparameters that we used. First one is learning rate. We chose a learning rate of 0.0002. Learning rate is a hyperparameter that determines the step size at each iteration while moving towards a minimum of a loss function. So, a low learning rate will take small steps and may get stuck in local minima, while a high learning rate may cause divergence and overshooting. So in this project, we chose 0.0002, which is a commonly used value for Adam optimizer. And the batch size we chose 32, which is also a typical value used for training deep learning models. So a larger batch size may result in faster convergence and more stable gradients, but it requires more memory and may lead to overfitting. So we set batch size as 32. So the activation function which we chose is leaky ReLU, which stands for leaky rectified linear unit activation function. So this peculiar activation function introduces non-linearity to the model, unlike ReLU, which helps in learning complex patterns. More details will be given on this later in further slides. And the alpha value we chose is 0.2, which is a parameter of leaky ReLU activation function, which determines the slope of the function for negative inputs. And the optimizer we chose is Adam, which is responsible for updating the model parameters based on the gradients computed during the back propagation phase in neural networks. More details will be given on this soon. And finally, the loss function we chose is binary cross entropy. So loss function is to measure how well a model is performing in terms of the task which we gave the binary classification for. So next slide, Vaibhav. So optimization algorithms are critical components of deep learning models that enable us to adjust weights and biases of neural network to minimize the loss function. The most commonly used optimization algorithm is stochastic gradient descent, which updates the neural network's weights and biases based on gradient of the loss function with respect to these parameters. However, SGD can suffer from problems such as vanishing gradients, where the gradient becomes very small and the optimization process slows down, or mode collapse, where the generator produces limited variations of the same type of output. So this is why we chose Adam optimizer. It is a popular optimization algorithm that combines the benefit of two optimization algorithms, namely AdaGrad and RMS prop. So based on this, we can also go for low learning rate, unlike SGD, to avoid vanishing gradient issue. Next slide, Vaibhav. So the problem of vanishing gradient problem occurs when gradients become too small as they
Yeah, Mr.
backpropagate.
Samuel, you have only 3 minutes left. Make sure it is done.
Yes, sir. So to avoid this problem of vanishing gradients issue through ReLU activation function, we chose leaky ReLU, which will uh, add non-linearity to our project. So vanishing gradients issue is covered in that way. Next slide. So the loss function we chose is binary cross entropy, which is popularly used for binary classification problem. Other loss functions may not be as effective because they're not designed for binary classification tasks. For example, mean squared error loss can lead to issues like gradient saturation and slow convergence. So binary cross entropy loss function is computationally efficient and suitable for this project. Next slide. My peer Shreyas will continue from here.
Thank you, Samuel. So, as my fellow author Samuel said, the above mentioned hyperparameters was used to achieve an accuracy of 94% throughout and a discriminator loss which is almost close to zero. So, these are a very novel model that we have built here. Next slide, Vaibhav. Yeah. So, to generate fake images using GAN, we wrote a function that in two input parameters. One is the class number, which basically is the digit that we want to generate, and the other is the number of images that we want to generate. And to ensure that the generated images are not replicas, there is a little bit of noise that is added to diversify the images and make them look more realistic. Next slide. Yeah, so for generating a single fake image, it doesn't help us in any way. So we used another function that generates all the classes from 0 to 9 images for a given number of image input. Next slide. In our study, we have modified the architectures of discriminator and generator models rather than just fine-tuning the DCGAN architecture that we have used earlier. We have implemented a number of layers and evaluation metrics which gave us a accuracy of 94%, which is considered to be a noteworthy for the given GAN model. And this conditional GAN can be used in a variety of instances. Here it has been used for generating digits from 0 to 9, but another use case could be like generating English cursive letters to generate whole sentences where there are 26 labels to train the data on. And my fellow author Vaibhav will give us a thank you note.
Thank you for the authors, reviewers, whoever helped us to publish our paper in the Springer conference, and my sincere thanks to the mentor in our university, Dr. Srikanth Tota, who helped us throughout this research, and we achieved this research paper in under his guidance only. Thank you.
So,
Okay.
yeah, you can say.
Why you got 94%? Why not more than that?
Sir, can I stop the share, sir? Or, sir,
Yeah.
actually, we tried of many different layer configurations, sir. But adding more layer as we took MNIST dataset, sir. The shape of the MNIST, the one image in MNIST dataset is of 28,28 shapes, sir. If we add more layers, then there is nothing but there is a decrease in accuracy, sir. We can't add more layers as the input shape is very low.
Okay. What difficulty you faced in development of this project?
Sir, as we mentioned, the main disadvantage of GAN model is mode collapse and vanishing gradient, sir. The mode collapse problem occur very frequently while we develop the GAN model, sir. Like here in the image, you can see there are noise in the image, sir. If we use SGD optimizer, the mode collapse problem we occurred very frequently, sir. It is the problem we faced.
Okay, you tell the training data 60,000, testing data 10,000. Why? On what basis you selected like that?
Sir, actually,
That's my doubt actually.
sir,
Okay.
we referred many research papers, sir. Most of the people were using 90% of the training data and 10% of the testing data. But here we mainly used most of the percent for training, because GAN needs more data, sir. Like if it is a classification problem, it doesn't need more data, sir. We divide it 50% for training, 25% for a validation, 25% for testing. But when it comes to GAN model, it requires more input data to train the GAN model, sir, so that it can understand how to replicate an image.
Okay, okay. Sunil sir, proceed sir.
Have you found any certain limitations while generating these random samples and all that?
Sir, can you please repeat, sir? Repeat the question, sir.
Have you found out any sort of limitations while generating these random samples?
Sir, limitations in the sense, if we train the GAN model on more epochs, then uh, the output we are generating, the handwritten digit we are generating is the GAN is drawing the line more thicker, sir. Like if we see the output here, it is we are looking, it is like the handwritten digit, sir. But if we train on more epochs, it's getting wider, sir. The thickness of the stroke is getting wider, sir.
Okay.
Yes,
Yeah, fine. Thank you for your session, Vaibhav.
yes, sir.
So you can stop your presentation.
Yes, sir.
Yeah, next paper is paper ID 242, Miss G. Anusha.
Good evening, sir.
Okay, ma'am. Yeah.
Sir, I am Vijay Durga, Assistant Professor. Instead of my student, I am requesting you the session chairs to permit me to give a paper presentation, sir. Why? Because my student is not feeling well. She is admitted in the hospital
Are you one of the
because of.
authors, madam?
Yeah, sir. I am her guide, sir. So
Okay.
I'm an assistant professor, Department of CEC. Myself, Vijay Durga, sir. Can I proceed, sir?
Yeah, sure.
Sir, with your permission. Thank you, sir.
You can. Okay.
Is this visible, sir?
Yes, ma'am.
Yes, madam.
Yeah, sir. Thank you. Thank you. So, our topic is predicting cryptocurrency price using multiple deep learning models. So, my topic, so these are the table of contents we are kept in this paper. Abstract introduction, research motivation, existing system, proposed system, and what are the models we are used in this, and result analysis, conclusion, references. Sir. So, coming to the abstract part, so nowadays the world is ruled the digital currency. So that particular one felt us to do this topic, sir. We are acquired with this one. So the brand new of kind of assets is known as the cryptocurrency. In general, we are having several types of cryptocurrencies at present all over the world. But instead of that, we are choosing the three different currencies, that is Bitcoin, Litecoin, and Ethereum, considered as the best cryptocurrencies. In this, we are used the RNN, that is a recurrent neural network, which is the best suited for forecasting the price for the several cryptocurrencies. In this, we are using the three different models, that is GRU, Gated Recruit Unit, LSTM, that is long short term memory, and bidirectional LSTM. These are the performs while examining the map percentages, that is the mean absolute percentage error. According to our experimental data, GRU gives the best output when compared to the other two models, which having the very low error rate. As a result, GRU is a model is the best choice for making the more accurate and timely forecasting about the prices of cryptocurrencies. So coming to the introduction, the Bitcoin was first established in January 2009. Uh, throughout the world, 40% of exchanges globally supported over 30 different currencies. So Bitcoin significant level violating the relevant to their currencies. So in this we are forecasting, we are having the blockchain code. So blockchain is nothing but having the very high security. And in this we are not nowhere chance to cheat the others, because of the mission running blockchain mechanism has access of the same list of blocks, and transactions can watch in the real time how these new blocks are being filled with the fresh Bitcoin transactions. So in the research motivation, previously we are using the for we are acquiring our currency, we are very fond of to put in the shares like goods or US dollars. But in this main objective is to enable direct value exchange between the two persons of everywhere. This indicates that network is not under centralized management. No government or no central bank has the authority halt operations or ability increasing or decreasing the value. Hence, this is motivated for to develop the work in order to predict the cryptocurrency price using deep learning models. So, in the existing system, the data works only mission ML algorithms, which is not giving the accuracy. So that is ML is not also suitable for the large amount of data. So for that reason, we are choosing the proposed system. These are the limitations we are having. So existing the classification approaches the less accuracy than regression techniques, and compared with the another languages, machine learning algorithms are the particularly inaccurate predicting the prices, and also we are having the less dimensions, and this is not suitable for the large dimension data set. So in the proposed set, I already told you that, sir. So in the recurrent neural network, we are choosing the three different models: GRU, LSTM, and bidirectional LSTM. In that also, GRU is the best model for giving the best accuracy when compared to the remaining two models. So this is the proposed model, sir. In the proposed model, initially we are downloading the data sets from the kaggle.com. Later on, we are pre-processing the data. Then we will splitting the data and training and testing. Later on, the data will transfer to the models. Finally, we get the output for the crypto price prediction. So these are the advantages for the proposed system. The results obtained by the GRU is the best compared to any other models, and the accuracy obtained was almost 99.24%, which proving is the GRU gives the best results. This accuracy is any kind of cryptocurrency to find the out of the price prediction. So in the LSTM, that is the long short term memory, we are taking the chain process, that is that data is depends on the initial and end one. We are taking the data is linked with the in the LSTM. So for that we are giving the TAN functions to bypassing the data in the LSTM. So in the gated reputed unit model, we are taking the type of neural network in the central cases having the advantages when compared to the LSTM, which is having the in the GRU we are having the less memory and faster than the LSTM. So in the GRU we are taking the important data in the short time of memory, and the GRU also solve the problems through two gates: the updated gate and the reset gate. These two gates are decided what information is allowed through the output can be trained and retained information from the throwback. So this allows the past relevant information down the chain of events of better making predictions. So this is the proposed methodology. In the proposed methodology, we are using the Python programming language to implementing the applications for the Google Colab platform to store the information and executing the project. So the below diagrams giving the RNN model performing the data set, and three models are finally which can give the more accuracy in the RN models to find the cryptocurrency price detection. In the result analysis, we are taking the data from the kaggle.com. Uh, so import libraries and load the data set. So we are taking the entire data stored in the pandas as a PD, and numerical data in the numpy, and the mathematical notations can be considered here. So here we are selecting the Bitcoin and we are giving the denominations here. So this is the application of LSTM model. We are having accuracy here 92.11% only. So here we are having the three models. In this model, bidirectional having the very less accuracy, that is only 20%. In the LSM model, we are having only 92%. When compared to the two models, GRU gives the best outcome, that is 99.241% with the better accuracy. So my conclusion is, in the RNN models, GRU is the best method for taking the uh, uh, things that is with having the low error rate. So these are the references. Thank you, sir.
Madam, how you correlated these various cryptocurrencies, ma'am?
Sorry, sir.
How you correlated? How you have shown the correlation between various cryptocurrencies that you have used? Have you taken any heat map or anything like that?
Actually, that work is done by my students and I'm not yet prepared well. So,
Okay. I mean, actually, if we are using these correlations between these exchanges and all that,
yes, sir, they
we
started
would be using
correlating
the
the
heat
data.
maps. So
Uh,
that's the
yeah,
okay. No issue,
yeah,
man.
yeah, yeah, thank you, sir.
Raghu sir, any queries from your end? Okay, fine, madam. We'll move on. So you can
Yeah,
stop your
sir.
presentation.
Yeah, sir, thank you.
We'll go to paper with ID 246, Miss Mariam.
Yes,
Hello. Yeah. Hello, madam.
hello.
Okay. What are the
Hello.
pre-processing data? Hello.
Yeah, Mariam,
Hello.
madam. Just a moment. Just a
Okay.
moment.
Okay.
Can you hear me?
Yeah, we can. You can start your presentation.
Can you see my screen?
No, not yet.
Okay.
Yeah, now it is.
Now?
Now it is visible. You can start your presentation.
Okay. Hello all. I would like to firstly thank you for accepting evaluation of my works. My name is Mariam El Jaadi and I am a PhD student from Hassaniya School of Public Works. Today, I'm excited to present to you my research wind farm design planning with varied hob heights wind turbines using PSO. As we all know, renewable energy is becoming increasingly important in today's world, and wind energy is one of the most viable and effective source of renewable energy. However, the designing a wind farm is not an easy task, and it requires careful planning and optimization to ensure maximum energy output. My, uh, my research paper follows the AMRAD model, which stands for, firstly, an introduction section that provides an overview of the research problem and sets the context for the study. Then, a method section that includes the design of the study, the different data, and the technique used. Then, a section that presents the results and discussion, different configuration resulted from the code, and finally the conclusion that summarized the main finding of my study. Wind energy is becoming an increasingly important source of renewable energy, with the wind farms being a common way to harness this energy. In this study, we aim to optimize wind farm construction in a two-dimensional space with variable hub heights using PSO. Our objective is to maximize farm productivity by putting each turbine in the optimal place with the least amount of wake impact and generate as much electrical energy as possible at the lowest possible cost, of course. Let's move now to explain the methods. The objective of our study is to maximize power generation, power production of our farm by putting each turbine in the optimal place with the least amount of wake impact. To achieve this objective, we must avoid or minimize the impact of the wake effects. I have used in my study the Jensen model, the Jensen model, who modeled the wake effect. The model uses a mathematical equation to predict the flow of air behind a wind turbine, which is known as the wake. The wake model takes into account various factors such as the wind speed, the size of the wind turbine, distance between turbines, and it predicts the speed and direction of the air in the wake behind the turbine, and how it affects the wind flow and power generation of turbines downstream. To reach this objective, we will define the objective function, formulate the problem, and use the PSO as an artificial intelligence method. Let's start by defining the objective function. So we know that the cost of wind turbines is one of the most important factors to consider when designing a wind farm. The Mosity cost function is a mathematical formula that's used to determine the cost of wind turbines based on number of turbines in the wind farm. The output power, of course, of the farm will be the sum of the power of each turbines in the farm. Our objective function will the Mosity cost per the total power of the farm. So if we want to minimize the objective, we will maximize the power output and minimize the cost, the construction cost. Let's now formulate the problem. First of all, I will present a table who summarize the different parameters of our farms. It contains the surface of the farm, the number of turbine, the wind speed, the air density. The model used to represent the wind farm is a 10.10 square cell, which is in reality 2,000 meter, 0.2000 meter wind farm zone. And turbines can be located in one of the squares, so we have 100 different locations within the farm. To achieve our objective, we will use the PSO algorithm. The PSO algorithm is a famous optimization algorithm invented by Russell Eberhard. We have used it to evaluate several wind turbine layouts and discover the most efficient turbine placement to decrease wake effect and improve power output. Let's now expose some configuration resulted from our study. Before I begin to expose the different results, we will mention that our study explored two cases. The first case is with constant wind speed and directions, and the second case is with constant wind speed and variable direction. In the first case, the wind flow from the same direction, and also the wind speed is constant. But in the second case, no, we have a variable of the variability of wind directions. Let's begin by the first case, which is the constant wind speed and constant direction. The first scenario from this case is using same hub heights of turbines. So if we use the same hub height of turbines, we have 20 turbines with hub heights of 18 meters, and we have producing a maximum power of 90.6 megawatts. But if we use 20 turbines with different hub heights, we have reached 9.69 megawatt as a power. So we have as a result that by using different hub heights, we can catch more the power from the wind, the kinetic power of the wind. Let's move now to the second case. As the same as the other case, we have used a scenario with the same hub heights and also with the different hub heights. So we have a wind farm configuration with turbines of varied hub heights, which generates 10.25 megawatts of electricity. And with different hub heights, we have here 80 meters and 60 meters. We have the configuration with similar central height turbines, but production is 10.12 megawatts. To sum up, this study used particle swarm optimization to evaluate the effect of placing wind turbine with varying hub heights in a small onshore wind farm, considering, of course, wind speed and direction. The mean results of our study showed that a wind farm with various hub heights generates more power even when the total number of turbines is the same. This is due to the fact that turbines with different hub heights can be placed in more flexible position, taking into account varying wind speeds and topography, resulting in reduced wake impacts and increased power output. My perspectives for the study: we can employ more economic methodologies to explore the wind farm's economic features, and turbulent flow effects can be investigated for more precise results. This study has provided valuable insights into optimizing wind farm design planning, which can contribute to the development of more efficient and sustainable wind energy system. And thank you for your attention.
Yeah, actually, Miss Mariam, I could see few other similar systems already being used using the same swarm optimization. So, how yours is different from the existing ones? What different you
Sorry,
have done in
how?
your what different you have done in your application compared to the existing applications?
I have choose to use two different hub heights of turbines.
No, even I could see few of them already being done. So, anything different from those?
If we are talking about power production,
Yeah.
but the power production is in the megawatts. We have with same hub height 10.6 and with different hub height 10.69.
No, what I would like to ask is there are some similar projects that are being done. So, how yours is a bit different from those? Okay. Srinivas sir, any queries?
What is the data set you taken, madam? Hello.
Sorry?
What is the
Hello?
data set you taken, madam? Data set.
The data?
Ah, how do you execute this project, madam? On what basis? What the tool are you using?
Sorry, can you repeat?
Yeah, what is the
I don't
reason of
get you.
using the PSO? Why you use the PSO in your project, madam?
Why I choose to use PSO?
Yeah, yeah. What is the reason you're using this PSO algorithm?
Because the PSO method can quickly reach the best solution in comparison with other materialistic algorithms.
Okay, okay. Okay, ma'am, thank
Okay,
you.
fine, ma'am. You can stop your presentation.
Okay.
We'll move on to the next paper with paper ID 251. Uh, Miss Dharani, Dharani.
Yeah, let me share my screen.
Are you available, ma'am?
Yeah, I'll present it.
Your voice is not that audible.
Can you
Make
hear
sure
me
you're
now, sir?
no, not yet. Make sure you're clear.
Can you hear me now, sir?
Yeah, okay. You can start your presentation.
Yeah, just a minute, I'll share this.
Okay.
Uh, can you please confirm if you can see my screen, sir?
Yes, we can see your screen.
Yeah, I'll start my presentation. Uh, Good evening, everyone. Let me introduce myself and my team before getting deep into what this paper is about. So, Dr. Raghavendra KV, Associate Professor, Pranavi, Satvika, Tejashri, and I, Dharani, from students from GE Narayana Institute of Technology in Hyderabad, under the encouragement of our CHD Dr. Sita, are here to present our paper, Early Stage Detection of PCOS using deep learning, with paper ID 251. It is really an honor to present our work in International Conference on Data Science and Artificial Intelligence 2023. So these are the table of contents of our upcoming presentation, where I introduce the paper and then talk about what are the uh, limitations of past survey, and then we will talk about proposed system, methodology, and then results. uh, a medical illness known as polycystic ovary syndrome or PCOS affects hormones in women who are fertile. Women who have PCOS typically struggle with significant symptoms listed, including weight gain, facial hair growth, pimple, hair loss, and irregular periods. In some cases, these symptoms may lead to infertility or even heart diseases. This issue this issue is addressed by this paper, where we proposes a method for PCOS early detection that makes use of ultrasound images of the ovary. So, coming to the literature survey of the previous work done in this PCOS topic, you can see different limitations from previous work. We found that many papers available on these topics are applying machine learning algorithms on data-driven PCOS datasets with mathematical values as the data in it. Some performed CNN models on scleral images. This might not come. Sorry, there seems a disturbance.
Sorry, Lakshmi madam, can you keep your mic in mute? Thank you.
Yeah, thank
Yeah,
you,
you
sir.
can proceed.
Yeah, thank you. So some performed CNN models on scleral images, which might not completely a limitation, but we have performed on some other data set to see what will how the results will be. And then there are papers where the data sets used are unavailable over internet, and finally there are some where they applied machine learning algorithms on PCOS ultrasound image dataset, which we used in this paper. Uh, in the midst of these limitations, we proposed a system to build a predefined CNN model and another model which was built from scratch, applied on PCOS ovarian ultrasound images dataset, along with combinations of two different actuation functions, sigmoid and softmax, applied on output layer of a network or a model, and observe the accuracies of all four different combinations. So let's get into it, into the methodology of the proposal system. The first and very important step can be data preprocessing. It is really important because the data available cannot be directly used into algorithm to build a model, as the dataset that we use is a images dataset. So there are since there are images in it, it will be really difficult for an algorithm to apply mathematical functions on it. So the figure here shows the or describes the data present in the dataset. So the dataset we used is a directory which is divided into test and train folders of a 3:1 ratio, which further divided into infected and non-infected folders, where the overall amount of images present are around 4,000 in it. So we perform data pre-processing using Keras library that provides a image data generator function to transform images into uniform notation in order to feed a model. So that function creates a iterator that will help to feed different data at different epochs of our training process. So epoch is just a single training cycle of the network. Now coming to the next step in the methodology, that is building the model. As we have pre-processed machine understandable or a matrix which contains numbers in it, data is easily processed right now. So we used two different algorithms, inception v3 and sequential CNN, along with two different activation functions which make it into four combinations. So this is the structure of uses of the inception v3 algorithm to build our model. So what is inception v3? Inception v3 is a predefined algorithm which take weights from training another data set of images or scenarios. It uses those weights as initial weights to start the training of the model upon a PCOS dataset. And we used Inception v3 model, which contains the layers convolutional, pooling, dropout, fully connected, along with the softmax activation function, which then layered with flatten and dense layers on top of it using softmax or sigmoid activation functions in the output layers. Let me also describe the architecture of another algorithm. Before explaining what these layers are, these layers do to our research. So this is the second algorithm that second CNN algorithm, that is sequential CNN. So sequential CNN helps us to build a model from scratch by layer by layer of our own prescript types with our own choice of activation functions. So the pipeline we used is a multiple occurrence of convolutional layer along with pooling layers, and they are again topped with max pooling and flatten layers, and then ultimately applying sigmoid or softmax to output layers. So coming to these layers now, convolutional layer helps to generate a feature map by converting pixels into single values, and pooling layer helps to reduce the size of the feature map and understand the patterns in the data. Whereas dropout layer helps to simply drop some neurons in a random basis in order to avoid overfitting, as CNN is a completely network based model. And fully connected layer helps us in usage of all the connections possible in order to add weight to the network. And then flatten layer just flattens or make the whole data into a single vector, which is mostly used on the output layers. And coming to the dense layer, it's just let the neuron copy the input of the neuron and give that same as the output. uh, you must have heard a keyword called activation function so many times in this presentation, but I really didn't get into it. So an activation function is a function that activate the neurons present in the network, just as its name suggests. We use sigmoid and activate softmax activation functions, just like discussed before. So these are applied on output layer in order to see the variation between two functions. So sigmoid function produces values between 0 to 1, where it uses logarithm to distribute output values, whereas softmax uses probabilistic distribution. And there are another activation function, as mentioned in the architecture, that is a ReLU activation function. So it is used in internal or hidden layers of the network, where it produces an output as 0 if input is negative, and input is if input is positive, then it will produce input it will give the output equals to input. Finally, coming to the results, so on the comparison of four models, sequential CNN along with softmax activation function has accuracy around 98.96%, which is near to 99%, and it is also have loss value less than compared to all the four models that we have built. So accuracy is just the number of correct classifications divided by the total number of classifications, whereas loss values are the values indicating the difference between the desired target state, whether it is detected as PCOS or not. So the accuracy obtained by inception V3 is 64.06% and sequential CNN is 98.96% respectively, using the softmax activation function. So the reason behind softmax sequential CNN getting more accuracy than other is that because each layer is stacked together, the whole network has exactly one and one input and output in sequential CNN, and in contrast, Inception V3 is a pre-trained model, as we have mentioned, as I have mentioned before, and since it is a pre-trained model, the weights are imported from some another data set, which may not be suitable for the ovarian ultrasound image data set that we have used. And along with CNN algorithms, sigmoid function is chosen over the softmax activation function because it gives sum to 1 as the output when employing softmax, boosting the likelihood of one class reduces the overall productivity of all the other classes. Increasing the likelihood of one class does not alter the overall probability of other classes when using a sigmoid function. So, to conclude this presentation, detecting PCOS is really important in a serious condition may make the adverse effects of it. So we proposed a sequential CNN model along with softmax activation function with the highest accuracy 98.96% to classify an input ovarian ultrasound image as infected or to PCOS or not by saving and loading loading the model that we have proposed. And we can, coming to the future scope of this project, we can enhance this by applying data augmentation in order to increase size of the data set and eventually accuracy, as present data set is about 4,000 images only. Thank you for this opportunity.
Srinivas sir, any queries?
What is the size of your data set? Hello.
Yes, sir.
What is the size of your data set?
It is only about 4,000 images, sir.
Okay. What is the source? From where you have taken the database?
Database is actually collected from internet in a from Kaggle website. We couldn't find ultrasound images outside.
Hey, could you go back to that accuracy? How did you calculate the accuracy?
So
So have you taken any positive and negative values of the detection and all that? How did you calculate the accuracy here?
accuracy basically we calculated by total number of correctly predicted values by total number of values that are
No.
classified.
Okay.
Yes.
In the one of the previous slides, you actually explained that one. Can you go back to that one?
Uh, I have talked about accuracy only in this slide, sir.
No. Okay. Okay. Fine. Yeah. Okay. You can stop your presentation.
Yes. Thank you, sir.
So next, we move on to paper ID 147.
Still, how many are completed, Doctor?
Four are completed, sir. 5 left, sir.
Okay.
Yes, sir.
So there are two presentations are left, sir.
2 were pending yesterday, but they did not join yet, sir.
Okay. Okay. So, okay. Okay. Let us see. Carry on.
Okay, sir. Thank you. So next to come in paper number 147, Malla Moulya. Are you available?
Yes, sir.
Okay, just a moment. I request all the participants who have done presentation, they can leave the session. If you are interested, you can stay in, but if you have completed your presentation, you can leave. Okay, ma'am, you can start your presentation.
Is my screen visible, sir?
Yeah, it is visible. You can start your presentation now.
Good evening, respected sir and dignitary fellow mates who are present over in this meeting. My name is Moulya and I am from Aditya Institute of Technology and Management, Tekali. I present over here to explain about our project, which done by our 4 teammates under the guidance of Priyanka ma'am. We have done a project named Hand Talk Assistance with TensorFlow Single Shot Detector. Here are the contents we are going to present in this conference. They are abstract introduction, problem identification literacy survey, observation from literacy survey, proposal solution, plan of action, dataset, tools used, algorithm, model analysis, experimental results, technologies used, applications, conclusion, future scope and reference. Coming to the abstract, as
Yeah, ma'am, sorry
communication
for
is the main
interruption.
role.
Just a moment. You have only 10 minutes to explain all this. The remaining time is
Okay,
for
sir.
queries. Make sure you are done in the 10 minutes.
Okay, sir. Okay.
Yeah.
As the communication plays a major role for people to interact with anybody. So, for a non-deaf and dumb people to interact with normal people, this sign language recognition model is very helpful. So, who are unable to communicate verbally, they can use this sign language detection model to communicate with their communities and with others. So the earlier system is not feasible. So means in earlier system they have used some hardware requirements and they have used some normal sign languages by using hand gestures. But in this model, we have used the single shot detector algorithm to detect different types of hand gestures and label them. So whenever we capture an image through our webcam, our model will detect type the hand gesture and which type of sign it is, and it displays the label. So my main motto is to detect and analyze different types of signs. Outcome is to make sure that deaf and dumb people can also interact with the normal people. The methodology we have used here is deep learning SSD model. And the specific introduction, coming to introduction, as communication, as I have already addressed, communication is very vital role to interact with the normal people. So this model will help us to reduce the gap between normal people so that they can communicate with the in social meetings or discussions. So we have identified that deaf and dumb people cannot easily communicate with other people. So they are facing some issues by recognizing different signs. So normal people cannot identify those signs. So model will play an intermediate between the deaf and dumb people and the normal people so that they can interact. These are some of these papers we have gone through. From this literature survey, we have observed that in some literature survey, they are using the gloves, and some in others, they have used the data set which is already taken. And in some other literature surveys, they have used some normal image processing techniques like CNN, which gives less accuracies. So we have gone through that problems and we have decided to build a model which undergo with the algorithm like SST. So we got the best results, and this SST model in this project we have taken the images through our webcam. So we have created our own data set, and this data set consists of alphabets like A to Z and digits of 0 to 9, which are signs of Indian Sign Language gestures. We have applied SST model to our data set and we constructed a model. This is the plan of action. First, we have collected the images through our webcam by using the OpenCV. There we have collected 1800 images, which contains A to Z images of alphabets and 0 to 9 images of numbers. And after that, we have labeled those images by using label image package. There how we have created a bounding boxes and label those images, and we have trained the model by using SST algorithm, so that the labeled images, with the help of the labeled images, the model will be trained by using SST algorithm and detect the signs in real time. This is the data set of the Indian Sign Language. It is the PROST. So data set consists of 800 images, which consists of A to Z alphabets and numbers. These are some of the signs. These are the sum of the signs of numbers. These are the tools we have used. Now, our fellow mate Salakshmi will introduce about the algorithm.
A very good evening, sir. My name is Sai Lakshmi. Here we are going through the algorithm. Have used the SSD algorithm, which stands for Single Shot Detector. Its main goal is to detect the images in real time. When comparing with the other algorithms like CNN, SSD is more beneficial because it detects many objects in an image in one time, and it also predicts the which object is present in the image along with its location. And here it is the layered architecture which is in the slide. The first one is it starts with the VGG16 model. It is the initial step. The network starts with the VGG16 model, and which is used for extract the feature maps. And SSD makes many predictions for a single class also. Here, this architecture contains 6 layers, which performs classification and also object detection tasks. And SSD will predict the 8732, will make the 8732 bounding boxes in an image, and it computes both the object and its location using the small convolutional filters. The layer which is called the object detection layer, it comprises of the two parts, which are extract the feature maps and apply convolutional filters to detect the objects. And the other one is the non-max suppression layer. Here the algorithm, whatever the objects are predicted, it calculates its confidence scores, and it removes any duplicate predictions present in the objects. And the scores are calculated based on the mean average precisions by using the intersection over union thresholds. And it will check the confidence scores of each box which is detected, and it will pick up top 200 predictions over the per image. And the next slide we will talk about the transfer learning and SSD MobileNet V2 model. This model uses the transfer learning. Transfer learning is nothing but it's a topic of deep learning. It deals with whatever the system is learned or the machine learned in the first task, it will be continued with the second task, and it will be continue over. It will make training and make the predictions on a new data set, and it will learn over and transfer learning to the second task and the predefined tasks. And also SSD net mobile net V2 model, which stands for multi-box
Next slide.
detection. And the next slide. Next slide will be continued by Satvika, fellow mate.
Good evening, sir. I'm Satvika, and the next slide is about our results. So the first three are about the numbers. So where we use it to show our sign, and it gives us the output. So first one is about 3, 5, and 6, and the belows are alphabets. So the first one is I, O, and T. And coming to the next slide. So the first one is the trained model and epochs, and that last one is about accuracy. So we got our accuracy like 95.6, and from different signs, so the accuracy
What's the
can be
accuracy?
changed. 95.6, sir, but for different signs, so the accuracy may be changed from one to another sign. So we took like normal I, so we got accuracy like 95.6.
Next.
So the next one is technology used. The next one is about applications. So basically it provides a
Next.
brief. So here
Okay,
we
so how many signs you have taken?
So we took like alphabets from A to Z and 0 to 9 numbers.
Okay, so how, see, those signs are meant for what? What is the meaning of each sign? How the other people can understand?
So
For
by
example, if you
labeling
show
those,
one, if you show A, what's the meaning of it?
Sir,
so
it's mainly for.
Am I clear what I'm asking?
yes, so it will
See
be
the,
helpful for
see the
the deaf and dumb people to communicate with the normal people, sir.
what is the communication? What communication is giving? How we can understand if a deaf people represents A? What is the meaning of it?
They will have a sentences like no, sir. If I am Moulya, like that they will define. If it is I, they will show that I symbol. So we can know it is I. They are showing I. Then
So
after that
finally,
they will show
finally
A
you are
and
taking. So finally, you are taking images which represents A to Z and 10 to 9, right?
yes,
And
sir.
you are identifying whether that image is the representing the thing what you are expecting, right?
Yes, sir.
For example, if he's showing, let us say, B through fingers, so we should
Yes, sir.
identify,
We
our
will.
system should identify it as B, right?
Yes, sir. Yes, sir.
Okay. So to which one you are comparing?
By
Is there
comparing
an existing
CNN, we
system?
have used.
Is there an existing system available?
Using convolutional neural network, it is available, sir.
So what is their accuracy?
Theirs is 75%.
How you know it is 75?
By a literature survey, we have gone through their paper.
No. Okay. Okay. Any other questions from other reviewers?
Pablo, how many images you have taken?
Sir,
How many images you have taken for execution of your
1800 images, sir.
1800 images? In that, how many are the training and the test?
Hello, sir.
In that, how many are the tests and the training data sets? How you split the images?
About 80% for the testing training dataset, and for 20% is for the testing, sir.
Testing or validation?
Sir,
Are you taking for the validation or testing?
for training 80, testing 20, sir.
Why you choosing the V16? Why not V19? VG19?
I'm not able to see.
You taken the VGC19, right? 16, I think so.
It is 16, sir. VGG 16.
So why not the 19? Have you tried for the VGC19?
No,
No,
sir.
sir.
Actually,
Not tried for VG 61.
Have you found any drawbacks in that? Or it is not suitable for your data set? Is there any reason?
No, sir. We have gone through with VGG 16. We have not tried with VGG 19, sir.
Yeah, why you not compared? Comparison is not shown in this paper presentation. Is there any comparison? with the present and current and proposed and the current system. Hello.
No, so we have not compared those algorithms. We just gone through with the papers and we have implemented this SST algorithm.
Yeah, thank you.
Yeah, okay, Moulya, you can stop your presentation. We move on to the next paper. So next paper is paper with ID 236. Ravi Shankar sir, are you available? Ravi Shankar sir, are you available? Paper number 236, paper ID. Ravi Shankar Kasireddi. Okay. Paper ID 236, not available. We move on to the next one, that is paper number 169. Dr. L.K. Indumati.
Yes, sir, available.
Okay, madam, you can start your presentation, madam.
Sir, is it visible?
Not yet, madam. We are waiting for your presentation.
Yes, sir. I'm taking that.
Okay.
One minute, sir.
Sure, ma'am.
Yes. It is showing as entire screen and window. Now it is visible, sir.
No, madam.
Now? Hello, sir. Now is it visible?
Yeah, it's coming.
It is visible,
Yes,
ma'am.
Thank you, sir. Good evening, everybody. Myself, Dr. L.K. Indumati, working as Associate Professor in the Maharashtra Engineering College, and my co-authors are Dr. Vijaypal Reddy, Professor and Head of the Department of CSA, and Mr. A.V. Muralikrishna is acting as Assistant Professor. And my today's title is an optimized mechanism to improve the performance of proxy mobile IPv6 using augmented open flow technique. Before going to enter into the topic, nowadays we know that mobile is very essential. Mobility is also essential. To make the mobility to be strong in the society, we need how should be the data packet should be travel from one device to another device or one node to another node. For that, we are moving for mobile IPv6. Even though mobile IPv6 is imparting in that aspect, it is not sufficient to go for the exceed manner of the mobility. So again, the scientist has been developed, IETF, International Engineering Task Force has been introduced, proxy mobile IPv6, which is essential for the nowadays situations. We are moving for more than one aspects like us up to 5G we have entered. And the concepts of today's data is not only the packet transferring, the packet which is consist of n number of data. Previously, we have transferred only the text and animations one. And nowadays, it is not like that. Embedded systems as well as our all set of controlling IoT mechanisms, everything is nowadays under control of internet. So definitely the packet should be transferred very properly. For transferring purpose, we are entering into the mobile IPv6. That is the main concept of my today's paper. And in this paper, we are focusing on, actually it is a large area. I'm focusing on the particular area of open flow technique. As we know that IPv6, Internet Protocol version 6 is one point, And that in that IPv6 we have entered in the mobile IPv6. Again we have entered in the proxy mobile IPv6. Proxy means additional concept which is need not required of mobile node participation during the transmission. That is the special case of the mobile IPv6. In that special case also, additionally we are importing local mobility anchor mechanism in the proxy mobile IPv6. To make that proxy mobile IPv6 is very strong, we are introducing the open flow mechanism. What is the open flow mechanism here means, normally when the signal is transferring, we cannot separate it as whether it is a data signal or control signal. Both the signals are combined, it is transferred by the air medium. Maybe the provider medium, maybe Airtel or whatever, maybe the medium we are utilizing, accordingly it is transferred. But now the technique is introducing the separation of the data plane and control plane. Normally, we know that whenever we are utilizing one protocol, it is having the control mechanism as well as it is having its own data. Both the things are combined and transferred into the signal. That is what generally nowadays also procedure is like that only. But in this aspect, we are separating that. Apart from that separations, it is easy to catch the data to the particular provider or X or Y provider. It is not the meaning from same provider to another, same provider. From one provider to another provider also, it is easy to access. That is the main aspect of open flow technique. And we know that IPv4 having 2 power 32 and IPv6 having 2 power 128 bit mechanisms. And in mobile IPv6, mobile node participation is not required. That is the main point, because in IPv6, mobile node participation is required. These are all the general introductions about the proxy mobile IPv6. And this is the general concept, what are the advantages and disadvantages of IPv4. IPv4, no, it is sufficient, less memory is sufficient, and existing infrastructure is support for what is existing. Nowadays, current technologies are not supported by IPv4, because once upon a time, we are not having a number of SIMs. And nowadays, it is not like that. Every person having 2 mobiles, and 2 mobiles each are having 4 SIMs or 3 SIMs. So everything we have to provide a unique IP address. It is not at all sufficient by utilizing 2 power 32 bit. That's why we are moving to 2 power 128 bit. That is what IPv6. And this is the advantages. Subnetting is not required. Security is high. Router can be easily discovered. Stateless, auto configuration, easily we can renumber. These are all the general benefits of IPv6. And this is the general representation. Normally, representation of IPv6 is hexadecimal. And the next is, this is the header. What is the main difference between the IPv4 header and IPv6 header means there was the main concept of next header representation. This next header representation having the concept of type of fields which is present in the IPv4, which is not present in the IPv6. So this IPv6 having the next header mechanism, this header leads n number of availabilities, which is not restricted as like as IPv4. This is the main aspect of IPv4 header. And this is the extension of header. By using this extension of header, what is the extension we required for the particular transmission? It is not mandatorily all the transmissions, even though we are not having any animations files. Only voice is sufficient. Means accordingly we can extend our header. It is not mandatory to go for all header extensions in IPv6. So this is the representation mobile and wireless mechanism. So wireless, it is the meaning, maybe the wireless device is stable or the wireless device may be mobility. So this is the terminologies, because before we going to enter, we should know what are the terminologies. Mobile host, it is a visiting network. Mobile home agent, it is the host where is the transmission is started, and foreign agent represents wherever it is transferring, and correspondent host next to what is the force is going to come, and mobility agent, this is the foreign agent. This terminology is responsible for care of address. And care of address concept in IPv4, generally in IPv6, we are having the mechanisms of communication of mobile node participation is there. That's why whatever that communication having, the mobile node will take care of everything. So in the mobile IPv6, the participation of mobile node is not there. That's why instead of that, one fellow has to take care of it. This care of address, binding cache, and binding update list, these people are taking responsibility of the duty of mobile node, which is, even though it is not present, these terminologies will carry out the details. And this is mobile IPv6 process, agent discovery. We have to identify which agent has to deliver the packet, how it should be registered, how it has to return to home. These are all the general aspect of mobile IPv6. So 4 important concepts in mobile IPv6. One is binding update should be there, binding acknowledgement should be there, binding request should be there, home address should be strong in there. So this is the ICMP, Internet Control Message Protocol, which is very essential for requesting address discovery, and we have to give the reply for address discovery management. And this is the data structure what is following in mobile IPv6 as well as in proxy mobile IPv6. This is binding cache, binding update list, home agent list. So this is the binding management, which are all the elements are involving in the binding management means mobile node, home agent, and correspondent node, and multiple care of address. So these are all the sum of the summaries of the internet protocol versions. What is the drawback? I already said that it is mobile node participation is not at all sufficient to carry out the data, and the packet transfer is not at all strong. That's why we are moving for proxy mobile IPv6, and this is the general explanation of proxy mobile IPv6. It is a layer 3 protocol. And one more thing in this, these are all the general terminologies as I have already explained. This is the overview. Instead of these are the two, LMA and MAG is the hard part of the proxy mobile IPv6. Now we are going to enter about how it is linked with OpenFlow technology. That is the main aspect of this paper. So remaining things I'm skipping. So what is the main issue means? Main issue, it is unable to cover the problem which is addressed by the mobile IPv6 as well as in the IPv6. These are all the problems of proxy mobile IPv6. So whenever we are moving for multi-homing, more than one interface, for example, I'm sending the data through Airtel, but my receiver is in any other company. Then what about the proxy binding? Then what about the border gateway protocol? BGP protocol is changed. When the BGP protocol is changed, how the link will be connected, how long time it will be taken, how much packets will be dropped, whether it is supported for live communication or not. All these problems will be raised in the proxy mobile IPv6. So this is the proxy mobile IPv6 problem. In pictorial wise, we have represented. So when the interface changes, the problem is raised much more, how it will be taken over. So this problem can be solved by OpenFlow mechanism. So this is the point what I have explained in the multi-homing, more than one interface when it is introducing. So this is what OpenFlow mechanical. It is mainly designed for switches and routers. In normally, general concept, we are saying it is only signal. Now we have to split it as the signal with the data plane and control plane. Who is taking care of it means our routers and our switches will take care of it. Normally, when we are routing the packet, router will take the vital role. After entering into the particular lane, switch will take care of it. But starting onwards in the OpenFlow, these two mechanisms, router and switch, will playing the vital role. The next, why we required OpenFlow technologies? Because today's n number of vendors are like Jio to up to Airtel, new peoples are coming. All the peoples, we are thinking that we are paying only money for our data. No, we are paying the money for our control signal also. If the control signal is centralized by one agent, the amount of money what is paid by the public, what is paid by the society will be reduced. That is the ultimate aim of the OpenFlow technology. What is the previous state of the OpenFlow technology means? Once upon a time, there is called as multiple label switching. MLPS aspect is there. In that aspect, they have introduced how we can separate the data and control plane. So these are all the things.
Please move to what is our innovation, what is our proposal?
Yes, sir. This is what. How does it is opening OpenFlow mechanisms, flow tables, controllers. So this is the necessity why the OpenFlow is introducing in the proxy mobile IPv6. So tunnel is not at all aspect. Here the virtual tunnel only we are keeping. Previously, general tunnel. So tunneling cost also will be reduced by using the OpenFlow mechanism. And additionally, this is already existing, which is OpenFlow mechanism is already existing. Now what we are introducing means augmented, extended OpenFlow mechanism. That is augmented proxy mobile IPv6, the ultimate aim of this paper. So this paper, what we have did means, by this diagram I will show you. This is the proposed system architecture. This is the OpenFlow. This is the LMA controller. And by using the intermediate switch, the data can be transferred from one aspect to another aspect. This is what the proposed system architecture. Now see, we can see the comparison of this diagram. The left hand side diagram showing what already existing, the right hand side diagram showing what already now what we are introducing. So normally a single aspect controlling the details through MAG is separate. Now it is not like that. LMA and MAG, local mobility anchor as well as mobility access gateway, both are combined in the augmented controller. This is what called as extension of OpenFlow technique. This is what the ultimate aim of this paper. Through this we can easily access the switch. So without any disturbance, packet can be transferred. So this is the technology for the simulation purpose. Actually, we have utilized the NS3 network simulator 3. So as we are moving for the simulation aspect, so we have to design the mechanism as like as the real aspect. So access switch, intermediate switch, so hop distance, how much hop distance we have to make, all the parameters should be given to that simulation, and we can get the result. And this is the system parameters what we have utilized for our simulation purpose. So layer 2 communication 0.2 seconds we have provided, and mobility access way to local mobility anchor we have given for 0.015 seconds, and mobile node to mobile MAG we have given to 0.05 seconds, and authentication delay we have given for 0.4 seconds, and delay control we have given for 0.5. By utilizing these system parameters, we have introduced the simulation, and the handover is the main aspect. By utilizing these parameters, we have introduced the concept of the simulation in the aspect, and you can see that this is the architecture, how it is had been worked. So control node, your internet switch providers, mobility access gateway, and this is the EOFT, that is augmented proxy mobile controller is sitting here. Authentication as normal as proxy mobile IPv6, it will work, but by the separation of control plane and data plane. That is the major difference between the open flow technique with the proxy mobile IPv6 without proxy mobile IP, without open flow technique. These are all the main difference between this architecture and previous architecture. And how we are positioning, this is the position mechanism, how we are making. Previously, the LMA is placing one place and the MAG is placing another place. In the augmented control mechanism, both are placed in the same place. So that is what the mechanism, we are easily gain it. And this is the tunneling mechanism. The tunnel can be forward the data. Here the virtual tunnel can be prepared, because normally end-to-end communication should be happen by the tunneling mechanism. That tunneling mechanism will be here carried out by the access switch and intermediate switch, so that the cost of the tunneling mechanism also will be reduced by using AU control, that is augmented open flow controller. And this is the configuration we have making for, because as we know that augmented controller have the data plane as well as control plane. This is the mechanism, it is showing in this place. And this is the algorithm what we are utilizing. First, we have to make the bidirectional tunnel and we have to hand over it. We have to binding the registration, virtual tunnel should be created and router should be solicited. And the AU controller should be registered with modified MAG, because mobile node is not participating. This modified...
Madam, it's already about 10 minutes. Complete as
Yes.
soon as possible.
Yes, sir. Yes, this is one algorithm. I will explain that. So mobile mobility, modified mobility access gateway now forward every places, and wherever the signal, wherever the data packet is moving forwarding, as like as mobile node, it is carrying all the details and transfer to the particular switches and routers. So this is the calculation we have made for proxy mobile IPv6, open proxy mobile IPv6, and our proposed mechanism, augmented proxy mobile IPv6. Finally, we come to know that mathematical calculation, and it is having the less amount of seconds, 0.615 seconds has been produced. And this is the proposed how we have fixed the sizes for simulation purpose. This is the simulation purpose details I have provided. And while we are comparing the analysis graph, we come to know that the handover delay is very less for extended open flow technique, that is augmented open flow technique, having the very less amount of handover delay. So I can conclude this mechanism is mainly support for handover delay will be reduced if we go for augmented open flow technique. This is what we want to show. Hello, sir, audible?
Has a little bit break, madam. That is fine. So what are the performance parameters, ma'am?
Sir, in this aspect, we have utilized only handover. Actually, some other performance analysis also there. Tunneling cost, signaling cost, packet delivery cost. These are all the parameters. By that also we can prove it. But for the one aspect I have displayed in this aspect, and remaining parameters also available, sir.
Okay, and how could you actually differentiate this proxy mobile IPv6 technology that is measured with your ones?
Proxy mobile IPv6 not having the communication of mobile nodes. Na? So once the mobile node is not at all participating, it is easy for the developer to separate the data plane and control plane, which is very essential for open flow, which is our paper, augmented open flow. That is why we have merged proxy mobile IPv6 with the augmented open flow mechanism, sir.
Srinivas sir, any queries?
No, sir. No, sir. No queries.
Thank you. So we shall move on. Ma'am, you can stop your presentation.
Thank you. Thank you for everybody.
Okay, thank you too, ma'am. So now we move on to the next paper with ID 228. Dr. G. Nagalakshmi, madam.
Yes, sir, I am here, sir.
Madam, are you ready with your presentation?
Yes, sir, yes, sir.
Your voice has a little bit of disturbance, ma'am. Please check once,
Yes,
and
yes.
you can start your presentation.
Okay, sir.
Sir, paper 236, can we present?
Yes, sir. I actually called earlier on time as per your schedule,
Yes, sir.
but no response was given. So we shall see at the end, sir. One more paper after this, then we'll come back to yours. Please stay.
Okay, sir.
Just
Right.
wait a minute, sir.
Okay.
Thank you, share. Sir, your enter screen is the presentation screen, sir. Window or the
Ma'am?
tab. How to share sharing screen,
Okay,
sir?
here you have an arrow mark symbol, madam.
Yes, sir.
The
Arrow mark.
fifth
Yeah, I
icon.
get
Click on that and select the option present the tab or present entire screen.
enter your screen means I get it same screen, sir. I got it
Present
same.
the tab. You can select either one, madam.
Just tab.
Better to select entire screen, madam. So no issue with that.
Enter screen, I got it only Google Meeting screen, sir. Share, share screen is visible, sir.
Yes, madam. Now open your PPT so that it will be visible.
My PPT.
Okay, ma'am. So open the slideshow so that it will be bigger and visible to everyone.
So it is visible, sir.
Yes, you can start your presentation, ma'am.
Thank you, sir, so much, sir. My name is Dr. Nagalakshmi. I'm working. I am assistant professor in mathematics department working in Geetham University. My co-authors is Dr. Sirisha, Dr. Amarnath, and Dr. M. Srinivasulu. Nagalakshmi and Sirisha is mathematics department. Amarnath and Srinivasulu is computer science department, sir. My work
Madam,
is
voice is little bit low. Can you check once?
yeah. Now okay, sir. Now okay, sir.
Yeah, now
Hello.
it is okay.
Yeah, sir. So my paper is
Yes, madam. No,
secure
okay.
way to message. Yeah, a secure way to message based on Internet Protocol and RSA algorithm using DNA coding with Laplace transformation computing. It is Laplace. It is one by one. Is paper presentation is abstract keywords, introduction, motivation, and contribution, proposal techniques, example, and analysis, and finally conclusions. Abstract means in this paper we approach the DNA, RSA algorithm, and Laplace transformation. DNA is one of the important algorithm, asymmetric algorithm. RSA symmetric algorithm. RSA is the asymmetric algorithm. Laplace transformation is one of the mathematical model, but in this paper we are presenting combination of these three combinations, that is DNA RSA algorithm with Laplace transformations belongs to public key cryptography, DNA computing technique, Laplace transformation with RSA algorithm to encrypt the message are using in this paper. This paper shows frequency analysis, time analysis, and statistical analysis to give a good result. Keywords DNA coding, RSA algorithm, Laplace transformation, plain text and ciphertext. DNA based cryptography is using so many ways. DNA based symmetrical cryptography, DNA-based asymmetric cryptography, DNA-based elliptical cryptography, DNA-based quantum cryptography. So many ways is that DNA is one of the part of the cryptography topics. So in this we are using the DNA and Laplace and RSA combination. This is the new approach to combination of these three. And Laplace DNA means it is characterized by using that ACDG with 0 to 1 binary code. We are simplify that characters in binary form. Laplace transformation, it is one of the mathematical form. It is the continuous integration. In this Laplace transformation existed that inverse function also. RSA algorithm it is one of the asymmetric algorithm. It is one of the popular and very well-known algorithm. So many works, so many companies are using RSA algorithm for security of the message or security of the data. Motivation and contribution is DNA is binary sequence, Laplace transformation is mathematical model, and RSA is the asymmetric algorithm. Proposed model presently a new approach to RSA and DNA using Laplace transformation. New message encryption is proposed to use RSA and DNA computation to transfer the message securely over the Laplace transform. It is similar to the RSA security, but reputations are not allowed. RSA algorithm, it is reputations are allowed, sir, but in this method is reputations are not allowed. DNA encoding algorithm is select a plain text, transfer into 8 binary string using ASCII table. Binary string converted into the DNA basis. 0 0 is the capital A, 0 1 is the capital C, 1 0 is the capital G, and 1 1 is the T. And binary DNA binary is converted to ASCII character values, and ASCII character values is converted into ASCII decimal values. And encryption processes start generate a positive polynomial f of t. It is a continuous function any f of t. Compute g of t equal to by message decimal values into f of t, and apply the Laplace transformation on both sides. We get it after simplification of message Laplace transformation into g of s. Apply the RSA algorithm on message Laplace transformation. We get it symmetric ciphertext. We get a ciphertext. Now print the encryption message. Decryption message. Now we are consider only trials systems. Sir, we are for decryption process we are taking the only 3 trials. First trial it is considered that convert the cipher message into ASCII decimal values and apply RSA decryption message. We get it message Laplace transformation. Apply inverse Laplace transformation on both sides. Automatically we get it message decimal values in terms of t. So now come to that complete the trials one. If come to the application after application of the inverse Laplace transformation, we get it decimal converts it into message characteristic by using the ASCII table, and converted in the message characters into decimal based DNA, and message DNA is converted into 8-bit binary. 8-bit binary is converted into ASCII characters. That ASCII characters is our output. If it is the correct way, we get it at that we get it the conclusion. Otherwise, it's stated that one more try. Come to that again. This process is continuous again because of our in these trials. Number of trials is very important for algorithm. Otherwise, fraud persons is tries that so many times. That's why we are in this algorithm we are taking the only 3 times, up to 3 times. When it is a 3 times is fails, we get back to the start. So this is the example of the entire algorithm. I will give that the table wise explanation. So this is the DNA plain text. In this I am taking the plain text is okay. After DNA application we get it the DNA plain text is this one, and it's 8-bit binary. ASCII codes is the 67, 65, 84 like this. And in this after Laplace transformation application we get it these are the values. After corresponding RSA encryption algorithm values are these are the values. Now applying the RSA algorithm, we get it these 2226, and this one is its corresponding 16-bit ASCII table values is these are the. So these are the completely unidentified characters. So this is the encrypted message, sir. Our original message is okay, but encrypted message is unidentified characters. We get it. So decryption process is reverse process. We get it the original message. So in this we are taking that experimental analysis, frequency analysis. Frequency analysis means in this DNA message okay, general plain text okay, converted into a DNA message CATT CGGGT. So its message DNA with RAC is the same frequency, TT is the same frequency, GG is the same frequency. Similarly, DNA with algorithm algorithm is also a same frequencies of TT. Repeated characters have the same frequency. But DNA with RAC Laplace transformation that is different frequencies. Here T is in this diagram, T is the different frequency and G is also a different frequency. That means in this experiment, repeated characters is not allowed. That is the one of the plus point of this work. And time analysis in this, we are taking that general text messages, sir. General text messages, 16 characters. Text one is the 16 bytes, text two is the 18 bytes, like that. So it is a random text, not a particularly general Word document text, sir. So by running the algorithm, it's taken 16 micro seconds, milliseconds, and RSA algorithm it's taken 10 milliseconds. DNA with RSA Laplace transmission 13 milliseconds. Similarly, it's a fifth text here we are taking the 336 bytes. So it's algorithm 167, RSA algorithm 150 milliseconds, and DNA with RSA Laplace transmission taking 245. And similarly, it is a little bit comparatively it is a little bit high time, but it is not at major one. I think so. I don't know exactly. In this we are simplified that we are not write that by using the .NET programming. We are running this algorithm by using the .NET programming, sir. And similarly, we get it time analysis of the decryption is also a same way. What is that? Text file is 336 byte size, file size byte is 300. LGML is 245, and RSA is 232, and finally DNA with RSA and Laplace transmission is 305. And statistical, we are simplified the statistical analysis for significancy purposes, sir. So in this statistical analysis is very important. So many ways we have the statistical analysis, the mean, standard deviation, regression, hypothesis testing, and sample sizes also. In this we are taking that Fisher F distribution hypothesis test. So in Fisherman distribution is taken to two independent normal populations. It's developed by Fisherman for behavior of the two variables for random samples. So what is the random samples is the plain text is the one of the random samples, ciphertext is the one of the random samples here. So here test statistics formula is F equal to greater variance by smaller variance, and F distribution it will take 5% of level of significance. Here random frequency is n minus 1, n2 minus 1 to n2 minus 1, where n1 is the number of samples of the plane, n2 is the number of samples of the ciphertext. So what is the calculated Fisherman value is we get it by using our programming output. It is the 10.99, and the tabulated value is 2.24. So it is hence it is tabulated value is less than equal to calculated value. That means there is no significance of the plain text and ciphertext. That means plain text and ciphertext is both a completely different way. So conclusions in this paper, the proposed model has uses the RSA and DNA based cryptography using Laplace transformation. The first step of the proposed method is DNA encoding of the original message, and second step of the step is the converted message applied the Laplace transformation mathematical model, and third step is RSA algorithm using the converted the message. The current work has three stages of the crypto system process. So the attacker faces very difficulty in getting the original message. Hence, DNA computing with the Laplace transformation with RSA algorithm process gives a good security. Due to frequency analysis, the proposed model uses different frequencies for every character by not only any repetitions. In the proposed model, the time complexity is similar while comparing the RSA and Algamar, the statistical analysis is entirely different from the plain text and hypertext. So the proposed model is good and good approach one. So it is the followed references, sir. These are the references. Thank you for any questions. Hello, sir. Hello.
Yes, ma'am. Yes. Srinivas sir, any queries?
No queries, sir.
Ma'am, actually, what are the, in which instances these can be applied?
We are write the program .NET, sir.
Okay. Practically, in which sort of applications this one can be used? It's actually a very good thought.
Yes. Applications, we are securing the messaging only, sir. RSA application is it is well in application.
Yeah, that I understand, madam.
We are combination of that
Okay, ma'am.
mathematical is Laplace is also one of the mathematical model.
Okay. Thank you, ma'am. You can stop your presentation.
Thank you so much.
Okay. Now we move on to paper number 241, paper ID 241. Kirti
Yes,
Dikshit, ma'am.
yes, sir.
So you can start your presentation.
Okay, sir. Thank you very much.
Nagalakshmi, ma'am, please mute your mic. Thank you.
Carbon.
Is it visible, sir?
Yeah, it is visible.
Okay. Good evening, all of you. Myself, Kirti Dikshit from Institute of Computer Science, Vikram
Just
University,
a
Ujjain.
moment. Just a moment, madam. Just a moment.
Yes, sir.
Sorry for interrupting. Nagalakshmi, madam, can you mute your mic? Yes, you can continue, ma'am.
Okay. Thank you very much, sir. Myself, Kirti Dikshit from Institute of Computer Science, Vikram University, Ujjain. My paper ID is 241 and my paper title is An Integrated Information Security Risk Assessment Approach. These are the contents of my today's presentation: introduction, motivation, security issues in small and medium-sized organizations, existing information security risk assessment methodologies, comparative study of existing ISRA methodologies, criteria for an efficient information security risk assessment approach, ISRA framework, ISRA methodology, results, followed by the conclusion. With increasing development of information technology, computing and network applications have become an inseparable part of any organization. Systems are increasingly interconnected and exchange huge amount of information. There are inherent flaws in the design and implementation of hardware and software packages referred to as vulnerabilities. These vulnerabilities poses risk to the system's proper functioning when a certain threat has the opportunity to exploit these vulnerabilities. So risk analysis is the process of evaluating these system vulnerabilities and the threats facing it. In today's complex security environment, new threats are emerging on a regular basis and vulnerabilities are increasing day by day. And if organizations are not constantly checking their systems, they are vulnerable to attack. Therefore, detection and remediation of vulnerabilities is crucial to ensure security. The risk analysis process should be conducted regularly to identify information assets and related security risks and then provides to the organization a prioritized list of risks that the organization must mitigate. An information risk assessment methodology is an approach that structures the assessment of information risk. It consists of a precisely defined sequence of phases, including their associated activities, inputs, outputs, in the form of a framework for information risk assessment. The objective is to execute these phases during the information risk assessment process, including but not limited to identification of information assets, the characterization of their associated threats and vulnerabilities, analysis of impacts and likelihood of the incidents, prioritization of risk. It also includes conducting a gap analysis and developing a plan to reduce the risk, followed by reporting the results. So as we know that asset is anything having value to an organization. Every organization has some valuable assets. When threats exploit the vulnerabilities, vulnerability expose information assets of the organization. When vulnerability increases, risk is also increases, and it indicates the requirements of protection. Control protects against the threats. As we know that vulnerabilities are increasing day by day. According to National Vulnerability Database, total number of vulnerabilities in 2011 were 4,172. In 2017, reported vulnerabilities were 18,114, which is gradually increasing, and 26,448 vulnerabilities were reported last year by NVD. So according to the size of the organization, we have divided organizations in four categories. Very small organization whose staff size is less than 100, small organization whose staff size is between 100 to 1000, medium organizations whose staff size is between 1000 to 10,000, and large scale organizations which have 10,000 plus staff members. We can see that organizations with a staff size of 1000 to 10,000 have 11.5% of vulnerabilities that are high or critical risk, while organizations with a staff size of 10,000 plus have 11% of vulnerabilities that are high or critical risk. As a result, these organizations need information protection. Due to budget limitation and a lack of sophisticated IT awareness, they confront considerable difficulties in building an effective and efficient information security control environment. Even in terms of information security, large companies profit from economies of scale. Due to financial constraints, resource limitations, and a lack of information security knowledge, small and medium sized organizations undoubtedly have a tougher time achieving a reasonable level of information security. 61% of small and medium sized organizations were the target of a cyber attack during the last year. There was a 424% increase in new small businesses cyber breaches last year. 60% of small businesses that are victims of a cyber attack go out of business within 6 months. 51% of small businesses, they have no understanding of how to protect themselves against cyber attacks. 50% of small and mid-sized businesses reported suffering at least one cyber attack in the last year. And cyber crimes cost small and medium businesses more than $2.2 million a year. So there are various existing information security risk assessment methodologies, some of which are qualitative while others are quantitative. We have analyzed each methodology on some basic criteria and identified pros and cons of each methodology. There are many approaches available for evaluating information risk, but each methodology has its strengths and weaknesses, making it challenging for organizations to select the best methodology for their unique situation. Thus, there is a critical need for an integrated information security risk assessment methodology that organizations can choose. So, from this study, we have identified some criteria which are essential for an efficient information security risk assessment approach. These criteria are structure, identification, techniques, training, functionality, guidance, usability, consistency, and tool support. So we can say that the structure of a methodology is high if the methodology is divided in phases where each phase outputs are clearly defined to guide the user step by step. The structure of the methodology is medium if the methodology is divided in phases where major activities in each phase are explained. However, inputs and outputs of each phase is not clearly structured. And we can say that the structure of the methodology is low if it is just a series of guidelines. So we have evaluated all the criteria on these three parameters. So according to these criteria, we have compared various existing methodologies and observed that though no methodology performs high in more than 4 criteria. So we have developed an integrated information security risk assessment methodology that perform better from existing methodologies. Here is the integrated information security risk assessment framework. In the first phase of the framework, we identify the critical assets of the organization. Then we evaluate existing security practices. After that, we categorize threats of the organization. Then we identify the network and web vulnerabilities of the organization and assess the risk level for these vulnerabilities. Finally, we develop security strategy and mitigation plan to secure our organization. After mitigating these vulnerabilities, we perform reassessment process. Here is the methodology of integrated information security risk assessment. In the first phase of the methodology, first we conduct the planning session, then we prepare a project plan, then we identify the critical processes of the organization, then we assess the impact of these processes on the organization, then we identify the critical assets of the organization, critical people of the organization, and finally we identify the security requirements of the organization. In the next phase, first we review the security policies and procedures that are already available in the organization. Then we prepare a security survey, and then we conduct this survey within the organization. In the next phase, we determine the threat sources, we develop the threat scenarios, we define the actors and the motives, and finally we examine the history of the incidents. In the fourth phase, we assess the network vulnerabilities of the organization, and we assess the web vulnerability of the organization. In the fifth phase, we evaluate each identified risk using a qualitative method which assigns a rating based on likelihood and impact. Then we assess each risk numerically by calculating its impact value to estimate its impact. Then we combine the results of both the qualitative and quantitative assessment and adjust the ratings if necessary. Then we prioritize the risk based on their combined qualitative and quantitative ratings. For known threats, the risk level is estimated and noted on the risk matrix based on its impacts and likelihood. In the last phase, first we describe the current security protection strategies, then we select the mitigation approach, then we review the risk to the critical assets, and finally we design the risk mitigation plan for the organization. Here is the comparative evaluation of ISRA approach from the existing approaches. It is the results of implementation of ISRA approach. So we have implemented ISRA approach on an organization's real computing environment. For network vulnerability assessment, we have categorized assets in 4 categories. That is network device, servers, workstations, and Wi-Fi controllers. And these are the results of network vulnerability assessment. For the web vulnerability assessment, we have mentioned identified vulnerabilities, its risk level, impact of vulnerabilities, OWASP mapping of vulnerabilities, and mitigation plan for the vulnerabilities. So these are the results of web vulnerability risk assessment. The first identified vulnerability is weak password policy and no account lockout. So this vulnerability, the risk assessment of this vulnerability is high. It was observed that during our testing, the application has implemented weak password policy. As when we entered the password 123, it successfully accepted the new password. The application also didn't implement any account lockout functionality when wrong password is entered for multiple times. The OWASP mapping of this vulnerability is 5, security misconfiguration. We have also provided the mitigation plan for the same vulnerability. So we introduce additional authentication controls, that is two-factor authentication. We suggest that please implement the following parameters for the password policy. Password should be minimum 8 character. The complexity of password should be minimum 1 capital letter you have to use, 1 small letter, 1 symbol, and 1 number. Password history of last 5 password to be maintained, and implement captcha and lockout after a defined number of incorrected password attempts to avoid this scenario. These are the screenshots for proof of concept. In the change password form, we entered weak password 123. We forwarded the request from Bubsuit, and we successfully changed the password. Application also does not have account lockout implemented. We sent a login request to the server and capture it via Bubsuit, and we sent multiple wrong attempts to the application. And application displayed wrong username or password message indicating there was no account lockout implemented. The next identified vulnerability is Diffie-Hellman modulus. It's
Ma'am, only
severity
2
level
minutes left to make it fast.
Okay, thank you very much, sir. So these are the results of vulnerability assessment. We have identified 9 web vulnerabilities. So the third vulnerability is unhandled error message. These are the proof of concept for the third vulnerability. Then the next vulnerability is click checking. These are the proof of concept of this vulnerability. The next vulnerability is vulnerable JavaScript dependencies, its description and impact. And this OWASP mapping is 6 vulnerable and outdated components. This is the recommendations for this vulnerability, and these are the proof of concept for this vulnerability. The next vulnerability is concurrent login. The severity level is low, and OWASP mapping is 7. These are the proof of concept for the vulnerability. The next vulnerability is version disclosure via banner gripping. The severity level is low. The next this is a proof of concept for the vulnerability. The next vulnerability is password field with autocomplete enabled. It was observed that during our testing, that autocomplete is enabled in password field of the web application. Most browsers have a facility to remember user credentials that are entered into HTML forms. This function can be configured by the user and by application that employ user credentials. If the function is enabled, then credentials entered by the user are stored on their local computer and retrieved by the browser on future visits to the same application. This OWASP mapping is 5. This is a proof of concept for the vulnerability. The last vulnerability is improper cookie attribute. And this is a proof of concept for the vulnerability. These are the result for the network vulnerability assessment. So these are the risk assessment result of network devices. We have mentioned the impact of the vulnerability, risk level of vulnerability, over observation, and recommendations or mitigation plans for the vulnerabilities. These are the network devices, risk assessment results. These are the risk assessment results for servers. These are the risk assessment results for workstations.
Yeah, please move to
These
conclusion,
are
ma'am.
Okay, sir. In this research, we have developed an integrated information security risk assessment framework and methodology. We put the proposed ISRA framework into practice in a real computing environment in an organization, and we studied the outcomes to show how effective the framework is. A thorough description of the organization's vulnerabilities provided. We have combined qualitative and quantitative risk assessment to uphold the security level of the organization. Our study has made a significant contribution to the discovery of vulnerabilities that assure security of organizations' overall system and the most crucial data. These are the references. Thank you very much. Any questions, sir?
Ma'am, actually, there is something called as information security risk assessment already in existence. So, what's the
Yes,
main
sir.
difference between yours and that approach?
Sir,
ISRA.
existing methodologies are either qualitative or quantitative.
No. I'm not talking about those
And
existing
we have,
methodologies. Straight question. We have something called as
yes, sir.
ISRA, Information Security Risk Assessment. So, how this is
ISRA.
different?
Yes,
This
sir.
integrated approach is different from normal ISRA.
Sir, I have studied various ISRA approaches. These are various existing ISRA approaches. Octave, ISRAM, CRAME, Oral, SIRA, IS. I have studied pros and cons of each methodology, purpose of each methodology, and then we identified the shortcomings of this methodology. And to avoid these shortcomings, we have developed a new
Can you
integrated
name a
methodology.
few shortcomings?
Yes, sir.
Can you
Yes,
name a
sir.
few shortcomings that you have observed?
Yes, sir. Yes, sir. If we talk about Octave, it's simple to implement. It doesn't necessitate huge teams or significant technology skills, but it does not implement mathematical computation. It employs qualitative methodology as opposed to quantitative approach. When we talk about ISRA, the initial data gathering phases and the preparation phases can be time demanding, and the lack of an expert might make the process more difficult.
Okay.
As it is, when we talk about CRAME, so we have identified the cons of each methodology.
Okay.
And after that,
So all of
with the help
them
of
can
prompts,
be we can
yes, sir.
overcome all of them using this approach.
Sir, I'm not getting. Can you repeat, please?
No, whatever cons that we have in ISRA, those can be overcome by using IISRA.
Yes, sir. Yes, sir.
Okay. Yeah, fine, ma'am. Thank you. So you can stop your
Okay.
presentation.
Yes, sir. Thank you very much, sir.
Now yeah, fine, ma'am. Now we move to
So
paper
paper
ID
230.
236. Ravi Shankar Kasireddi.
Yes, sir.
So you
I'm
can start
presenting
your
my.
presentation.
Yes.
I request other participants to mute their mic.
So is it visible, sir? Good evening, sir.
Yes, it is visible.
Our research paper is about deep learning based surroundings descriptor for visually challenged. We are from Geetham University at Visakhapatnam. So, our agenda is this is our agenda, sir. And now coming to abstract. So the biggest challenge for a blind person, especially the one with complete loss of vision, is to navigate around places. Obviously, like blind people roam easily around their house without any help. But what if they go out? Then there will be a people with like there will be so much problem. So our research paper is about deep learning based surroundings descriptive for visually challenged, which aims this to make a software that helps visually impaired and blind individuals in perceiving and understanding their surroundings. So visually challenged persons are not able to enjoy the surroundings and nature as normally we do, and this research paper aims to improve their quality of life. So our software capture the images to detect environmental features and then provide real world auditory feedback to the user. So our research work goal is to create a reliable user-friendly assistive technology which can be adaptive and an affordable device software that improves the visually challenged person's life and makes them independent and allow them to move around more safely and confidently. So by this they become more independent than before. So this research paper uses several deep learning algorithms and NLP technologies such as VGG16 and LSTM. So coming to VGG16, it is a 16 layer deep and it is advanced CNN. So it is used for image recognition as everybody knows, and it has 3 into 3 convolutional layers for finding patterns and 2 into 2 pooling layers for reducing the spatial size of the input image. And while coming to LSTM, that is long short term memory model, it is used to learn, process, and classify sequential data. So by this research paper, it is used to develop the mental map of surroundings for and greatest access to the visually challenged people. So, the surrounding descriptive technology aims to solve the difficulties that usually impaired people face when navigating their surroundings and improve their experience of life. Our research paper includes technology design and development, system testing and evaluation, which improves the model based use on user feedback. So we use assistive technology, sir. Now coming to the objectives, So coming to the objectives, not able to see is a global health problem as everybody know. It describes any loss of vision that cannot be corrected by glasses or contact lens. According to the World Health Organization, 1 billion diseases in vision can be prevented or cured affecting 2.2 billion people. A person's quality of life, including the ability to perform daily tasks, education, work, and social interaction, can have a significant impact on vision loss. So, in recent years, there have been a significant advances in assistive technology to support visual impairments, including wearable and embedded system devices, computer vision, and machine learning approaches. So, these technologies aims to provide people with visual impairments with increased independence and access to information, education, and employment opportunities. So, the next will be continued by Ravi Shankar.
Yeah, sir. Next slide. So this is our proposed methodology, sir. Here we are importing images, captions. For both we are using the pre-processing and feature extraction, and then we are testing and training the data, and we are training the model and measuring the accuracy, prediction of the captions accurately with the image and the text, and then the output is the text to speech. Next. So this is our system methodology. So here our project mainly deals with two parts. First, pre-processing the images and captions and extracting the features from the images. The second one is training the model with the image features and captions, and finally predicting the output. Here, importing images and importing captions. Visualizing is the term we are taking this data set from the Flickr 8K, and Python libraries like Matplotlib or Willow can be used. And image pre-processing here is improving the quality of image by resizing, normalization, and other image pre-processing like grayscale conversion, data augmentation, rotation. And text pre-processing is that training the model to understand the text like start sequence and the end sequence. And finally, we are doing the feature extraction. It is a technique extracting relevant and distinctive features from images that can be used for further analysis, for the problems identification, object detection, and the image retrieval. Feature detection is an important step. Here we are using through an VGG16 model. Next slide. So basically, this is image data and text data. Our dataset consists of 8,000 images. Each image predicts within 5 outputs in the set 5 sentences. So 8,000 images into 40,000 captions. Each caption is predicted accurately through an image. Our model will train with 5 captions. The most accurate predicted by the model will be taken as an output, and the text data will be depicted as the final output of this project. Next slide. So basically, we are using CNN. CNN is a convolutional neural network. This can only able to make convert, pool, and max pooling. But in advancement of this, we are using VGG16. It's an in-depth of 16 layers, which is mainly deals with localization and classification. Our project deals with the localization of images, like extracting main object detection from the images, and extracting through that and as a captions, and predicting the output to the text-to-speech. And we are also using an LSTM. It is a type of recurrent neural network. We are using this LSTM to avoid vanishing gradient problem through an RMN. This is a successful pre-processing continuous data like prediction, time series, audio, text, and we are using this text pre-processing. For the reason, we are installed LSTM and VG16 as our main input models to this project. And for the further project continuation will be done by Ravi Shankar.
Okay, thank you, Karthik. Now I'll continue from model training. As we can see here, it is a graph we have plotted from Matplotlib library. We can see with increasing number of epochs while training, the loss is decreasing. Like the model is training well. That means by increasing the epochs, the loss is decreasing, which means the training is well by increasing the epochs. Here we can see the validation data. As Karthik said, the text data, which has 5 captions here. These are the actual captions. And here we can see the predicted caption here for this image. Here, this is a validation data, so it will give the accurate prediction for this. This is almost similar to these 5 captions. As we can see, the policeman is wearing yellow jacket. This is the representation of validation data. And now coming to the accuracy of our model, we are using Blue Score for our accuracy. Blue Score means bilingual understudy. Here, Blue Score actually means here we are predicting the sentence, so it will find the probability of the correct words in the sentence by the total number of words. Here we got 0.523. Generally, it calculates the accuracy in between 0 to 1. So we got 0.523. 0.4 to 0.6, the values between 0.4 and 0.6 are best values for language translations, and values greater than 0.6 are generally greater than human translations. We have plotted the graph also here. The graph represents the here the graph represents the Blue Score for every caption. Here we can see the values between 0.4 and 0.6 are more, and there are also values more than 0.6. So our model is predicting well. And this is the front end we have created using Flask, which is a Python framework. This front end we mainly created to test our model. As we can see, I uploaded an image here, and it gave output of the description, which here we can see the woman browses through the ornaments, which it clearly predicted the description. And quickly coming to the conclusion, here, as Purvi said, our project aims to create a software for giving us description for images, not only description but also audio description, which helps visually challenged persons to know their surroundings clearly. Like the visually challenged people are not able to enjoy their surroundings and not able to know their surroundings. So we mainly aim to let them know their surroundings to make a software. The software can be then implemented using any other embedded devices or any other IoT devices. But our main goal is to just create the software. And this research can be further developed by using a bigger data set and greater computational devices to have a more accuracy. And we can even develop the project to give a normal user feedback so that we can get even much better accuracy. Thank you.
So what is your current data set size?
This is 8,000 images, sir. We are using Flickr 8K dataset. So
Okay,
it is
and
8,000
you're
images.
saying that this assist visual rate, is it something a wearable device, something sort of wearable device?
Sorry, sir?
Just a software.
Sorry, sir?
Is it a wearable device or just a software?
No, sir. It's just a software. This software can be then implemented by any other embedded devices or IoT
Okay,
devices.
that's what
We
your
just make the
future work
software.
is.
Yes, sir. Yes, sir.
Okay, fine. Yeah, thank you. Sir, Srinivas, sir, any doubts?
Have you compared any algorithm with existing system?
Sorry, sir?
Have you compared this algorithm with any other algorithm?
We have used VG16 and before we have used GoogleNet, but the accuracy is very low, sir. So we have gone with VG16.
How much accuracy
VG16
they got?
for VG16, as we can see from the presentation, it's 0.523, sir.
Okay. What is the size of the image? Pixel
Sir,
size? Resolution. Resolution of
resolution
the image.
generally it's a variable, but while we are processing it, we are making it into 224 by 224.
Okay. How many effects taken for the training?
We first took 30 epochs, sir, but it was very long. Like the accuracy was, the loss was increasing after 27 epochs, so we stopped at 27 epochs.
Okay, thank you.
Yeah, thank you, sir.
Yeah, thank you. You can stop your presentation.
Yes, thank
So
you.
now, okay, now we move to paper ID 178. Jagannatha Varma, sir.
Yes, sir. Good evening, sir.
Good evening, sir. You can start your presentation.
Yeah, just a minute, sir.
Make sure it is completed in 10 minutes.
Sure, sir.
Okay. Yes,
Sir, is
sir.
my
Your
screen?
presentation is visible, and open the slideshow so that it can be enlarged.
Yes. Sir, is my screen is visible now, sir? Slideshow.
Yeah. Yes,
Yeah.
sir.
A very good evening to all the panel members who have been present in this. Myself, Jagannath Verma, presenting paper ID 178 with the title of Survey on Emerging Optimal Encryption Techniques in the Field of Cloud Data Forensics. Sir. While coming to the recent days, as a cloud usage has been more, in most of the surveys, it has found that most of the cloud potential customers have been worried about their data access, who has the access for their data, and demanding more awareness of what is going background in the physical system. So, in this context, there are certain concerns which are need to be discussed. One is about how can we prevent the threats to the information resources in the cloud, and second one is that how do we prevent the unauthorized access to the cloud infrastructure resources. For that, we need to define the threshold range to describe the access structure and how to reduce the computational cost of the information retrieval from the cloud resources. So the basic idea, the need for this particular thing is that as a cloud providers are not fully trusted by the users, while the data files stored in the cloud may be sensitive and confidential, such as a business plans. So in order to preserve the data privacy, the basic solution is to encrypt the files and then store the encrypted data in the cloud. There are several security schemes that have been proposed up to date for efficient and secure data sharing on the untrusted servers. In all those approaches, the encrypted data files are stored in a trusted storage and distribute the corresponding decryption keys only to the authorized data owners. But the issues of user revocation and multiple owner manner have not been addressed every efficiently in these schemes. So here the challenges are in an IT infrastructure, the attacker will give so many number of new attack vectors. If some group of people who have a strong control over the cloud computing account and a private authentication framework, the group of the people will have a full control of IT infrastructure. If any one of the people is not cautious, an attacker can easily get hold of the total powers, like what an owner will be having. So that the cloud stores lack the ability to manage the data provenance. So in a distributed multi-layered infrastructure like cloud, verifying the chain of custody is nearly impossible. So in every forensic investigation methodology, collecting evidence is significantly vital, which is not feasible, completely feasible in cloud computing. The current forensic investigation practices do not match the cloud computing characteristics. So I have proposed a method where the cloud system consists of data owners, users, cloud server, and TPA, third party auditor. Initially, our system consists of a three phases: setup phase, like key generation phase, and the storage phase. At the first phase, the data owner reveals their information, and next in the key generation phase, the data owners encrypt the data and generates data owners get their key. If the data owner stores the sensitive data to the cloud servers, he will be encrypting the document. After encryption, the data stored in the cloud with an access structure that specifies which type of users are allowed to the document. This access structure is been in our in this particular paper. We are defining this access structure using a threshold limit, which is been proposed by using a Kuko search algorithm, which seems to be an optimal threshold range. So with this particular threshold range, easily TPA can third-party auditor can track the dishonest users identified. In order to reduce the computational cost of the proposed method to retrieve the information, here we will be using the split the information and stores the data in the two different servers. So this is what I have been made a survey. These are the references where I have taken what are the previous works which have been done and their corresponding advantages and the limitations and what sort of a measures they have been considered in their work, sir. So basically, as I said, that the cloud is based on the cloud storage is based on the cloud computing concept, which has a lot of different features. The structure of data management on ownership makes it hard for the data forensics to protect our privacy. So in these things, the encryption, previously we have been using the encryption, but there is a lot of work need to be done for protecting our data and who has understanding about who has access to complete our data. There is a still of lot of work can be done in this particular area. We can say that the cuckoo search is been better somewhat when compared to the previous solutions to give an optimal solution in terms of securing our data. Thank you, sir. Any sort of queries?
Srinivas sir, any queries?
No, sir. No, sir.
Jagannatha Verma sir, can you give one practical example, the difference between previous system and this one?
Sir, pardon, sir.
Can you give one real-time example that how this differs from previous system? Even previous
So,
systems are also providing proper security for private clouds and
yes, sir.
all that. So how
I'm
it
not
is going
saying
to
that
differ?
they are not providing the things, sir. basically something like some sort of an attacks when they happen, it
Okay.
is not possible to find out the who has made that particular attack. So in that case, identifying the users who has a proper control access to the data is a vital role, sir. Is a key aspect in that particular thing. So what we try to do is that mentioning then a threshold range that to basically in order to do that particular thing, we are using a COCO search algorithm to find out the threshold range. So basically, we are defining such that who is the owner of that particular data will have only a certain range of a threshold where we will be informing to that particular third party auditor. So apart from that particular people, we can the threshold range for the other people will be having a more. So easily you can identify that he is an attacker.
Okay. Got it, sir.
Thank you, sir.
Yeah, thank you, sir. So with that, we conclude today's presentations. So I thank all the participants on behalf of this second international conference on data science and artificial
Sir, what
intelligence.
about 73, sir, ID number?
Sir?
73.
So actually, Bose Babu sir said that that person is actually taking the reviews.
Okay.
So maybe that will be done in another session. So as
Okay.
of now, that is the only pending one. So thank you, sir. And with this, I am closing the session.
Thank you very
Okay,
much.
thank you. Thank you.
Okay, sir. Thank you also.